Okay, so this is our capstone project. Numerous people. Um,
Assist citizens during and after devastating hurricanes by providing sustainable power in towns and cities.
so essentially,
We have a lot of things. Our main reason why we have this is because we're supposed to use a machine that helps with major emergencies such as floods, hurricanes, and build energy, which we'll talk about later. This is our design. It's called the water column generator. Basically, we have the water column. We have a wall to protect it from water and debris. And then we got the inner turbine, which will use air pressure. And using that, we can, it will spin the turbines, thus making energy, which will go to the transformer and then the generator.
okay, so our goals are affordable and clean energy and partnership for the goals because it helps with natural disasters and also provides energy for communities using the electric system. So how the issue is solved. So during huge hurricanes, there's a lot of waves, and essentially what our machine does is it takes the wave power and it turns it into electrical power, and it uses it to create backup energy for communities during and after natural disaster. It's built below sea level, so it's also stable for hurricane.
Alright, so this is our business plan, and some of the benefits of wave power is it has a similar output of energy as wind turbines, and because of the close vicinity to the consumers, the transportation costs are super low compared to other energy sources like oil rigs, where they have to go from the ocean to the land and back to the consumer. And then so the need for our product here is there's frequent power outages and infrastructure damage in many places around the world, and basically our product helps to solve those issues and keep those places with power. And then so our target audience is islands and archipelagos where energy is a rare commodity, because our product would basically supply these guys with energy whenever they need it and whenever is necessary. Okay, so we plan on getting our funding from the public because we are branding ourselves as a non-profit organization. So we'll gain funds through fundraisers, and we plan on accepting sponsorships and partnerships from larger companies that plan to promote their product through ours, which will just help gain more money so we can build more structures all over the place. And then the cost of one of these things is between 1 to 2 million, and which may originally seem like a lot of money, but when you think about it, oil rigs cost anywhere between $20 million to $1 billion, with another $200,000 a day to upkeep. So it's really on the cheaper side of power. And then there is our cost breakdown. So the biggest portion of our money will be spent on the actual structure rather than the upkeep. So that makes it really efficient and better than some others.
Okay, so this is the timeline of the project that we will be developing. First, we conduct it into the market, then we create the product, and then we test the product, and then we execute the marketing campaigns to promote to the public eye. That means we provide the idea to the public, and then we use the initial funds to create the first OWC of the island territory, mostly to Puerto Rico, since it has the most amount of problems. Continue to gain more public funding and public support of seeing success from explore opportunities for growth and expansion of the product or service internationally, and construct more structures in multiple locations and increase the level of power and security across the globe.
Okay, so here's where we used ArcGIS to discover where main power lines were, because in Hurricane Maria, it hit Puerto Rico, and you can see the blue line shows the path of the hurricane, and the red and the purple and the blue up there show the main power lines and power systems, and the red is the main power system of Puerto Rico, and it got hit really bad by the hurricane.
Back in 2017, a major hurricane called Hurricane Maria hit Puerto Rico, thus they lost power for 328 days. With our design, it could help with at least backup power, which would help with the building process to rebuild society, and it would make things a lot more simple.
These are references. Thanks.